Okay, I'm going to show you how to align a non-georeferenced point cloud to a georeferenced one in Cloud Compare. So to start with, we've got a model of Wallace Hall that we've loaded here. I'm going to reload that just so you can see what settings were used here. This is a 25-meter buffer around Wallace Hall, pulled from VGen LiDAR data from, I don't know, 2019 or something. I'm just going to, because I don't care about any of this stuff, I'm just going to uncheck it and load it with just the intensity values. As usual, when Cloud Compare loads one of these georeferenced point clouds, it's going to suggest a global shift. And so you can just hit OK. You don't need to pay attention to those values for now, but the fact that there's a global shift going on is kind of the important part. We've got the cloud loaded here, and the cloud that we actually want to reference to it is a GeoSlam cloud that we collected. So I'm just going to take this 9% version here. It doesn't need to be amazingly well detailed here. And this time I'm going to load everything in there again with just the intensity. No RGB information was captured along with this collection, so there's no need to bring those fields in. This just takes a second. All right, so that cloud has come in, and as you can see, it's been shifted. Now, no prompt was given here for a global shift, and that's important because there is no global information. This cloud is not georeferenced at all. And if you click on this, you can kind of look through the settings here, and you can see that there's no global shift at all. That's listed right here. So global shift is listed as 0. What we want to do is we want to make that match to this one. Before we start, we want to align this cloud to this one, but unless we apply a global shift, it won't save those. It won't put them in sort of real coordinates, which is what we want. So we're going to go to Edit and do Edit Global Shift and Scale. The original here is 0. What we want to do is the last input, so we're going to use that last cloud that came in, and we're going to hit OK. So when we do that, it's going to apply the same global shift. You can see that in the information here, now we've got a global shift that's applied here. Remember that all of this stuff just happens in memory, so we're going to want to save this back out again. So we're going to save this to the desktop as, we'll just call it shifted.las. I happen to know that the millimeter is probably sufficient for this, so we'll just change that while we're doing it. All right, so we've saved that back out again, and if we load that new one back in, what we want to find is that it now prompts up with this global shift, and it should be aligned to the last one, so we'll hit OK. And if everything has worked out well, what we'll find is that this appears kind of right where we left it. And now, the reason that that's important is we can start aligning it finely. I'm going to export these to a scalar field so we can look at it and apply a little bit of a filter. So we want to make these things match, which is kind of the whole objective here. So we're going to be using the translate rotate. The rotation is going to be, just kind of, you can use your left mouse button to key this in here. The shape of the building, you can sort of see some notches kind of on this back end, so that's kind of what we see here. I like to do these in a couple of steps, but you can kind of do whatever. I'm going to uncheck that translate on the Z, and now if I hold down the right mouse button and I drag it, I can kind of get to the same, I can get kind of to the rough same point. Now if I uncheck these and check this back in again, I can kind of get it to the point where it kind of matches up. And I can do this a little bit more finely, but that's essentially the step that you would take to get these two things aligned. There are tools up here. Here, I'll turn this on. There are tools up here that kind of do this. The iterative closest point algorithm is right here. So this is what finally aligns meshes. Whether this would work in this case, I kind of suspect not, because this is kind of an interior versus exterior scan. But in any case, One last bit here, we'll notice that we've got a lot of extra stuff. The range on a Velodyne scanner is pretty big, and so we probably don't want any of this stuff. So we could just sort of scissor some of this stuff out. A little nicer. And then save back out again as, let's say, aligned.las. So like I said, that's a rough cut of the alignment. You would definitely want to go in. You can sort of see that we've still got some alignment problems to do. But the key bit here is that now when we bring in our aligned point cloud, that we get this global shift coming back up again. And it will drop in the same location. One final bit that I'll mention: we definitely want to project this point cloud. The original point cloud is listed here, maybe back in our history, but when we loaded this in, there's a reference. The spatial reference is given right here, and our new one doesn't have any spatial reference at all. And so if we do something like load this up in ArcGIS, we also want to take the extra step of applying defining the coordinate system that this is in. So we'll just do a second part of this quick to demonstrate that. So I'm going to load this without a template. We're going to go back to our LiDAR scan here, and I'll just drag this in there like so. So here's our LiDAR data for Wallace Hall. The reason that we want to do that is we want to use that to mark the other one. So we're going to drag aligned.las in here as well, and this is where we get this message that says this is an unknown coordinate system. Because we had already dragged in, and this is why we did it, because we had already dragged in one that did have a coordinate system, it's going to guess that it's the same one. But to make this kind of a durable, we want to make this projection stick, we're going to use the define projection tool. So our input feature class is going to be this aligned. You'll see the unknown coordinate system pop up here, but what we want to do is just pick this from Wallace 25, which is fascinatingly incorrectly listed here as UTM Zone 1, so that's strange. But we'll go ahead and hit run for now. That should be 17. In fact, yeah, I don't have a great reason to suggest why that would be incorrect. It's definitely located in the right spot in Blacksburg. So we'll leave that as a mystery for next time. All right, that's it then. Thanks.